Good morning, seventh graders. Welcome back. It is Monday, January 4th, and I hope you had a wonderful break, was able to just rest and relax and recharge a little bit before coming back. And so here we are. We're going to get going. And so first off, I just want to say thank you to Mr. Terpstra for teaching Chapter 3 with integers with all of you, and Mr. Cheney for doing 1 week of Lesson 4, or Chapter 4, with some rational numbers. And now we're going to head into Chapter 5. And with Chapter 5, you're actually going to be seeing myself and Mr. Whalen. We haven't seen Mr. Whalen yet, so he's also going to be helping out teach Chapter 5. So that'll be the month of January. And so between now and then, for the next 4 weeks, you're going to see me a couple days and then Mr. Whalen a couple days, giving you all your awesome 7th grade math material. So we're going to start Chapter 5, and one of the first things I'm going to talk to you about is just the essential question in the upper left-hand corner, and it says, how can you use numbers and symbols to represent mathematical ideas? And so we'll see that as we go through the chapter. We're going to actually start today with just understanding some of that vocabulary and what an algebraic expression is. So knowing we're going to start Chapter 5, you are going to need your Volume 2 math book from here on out, and so that mentions that on the agenda there. We won't get into the math book today, but we will definitely start using the math book tomorrow. So we'll use it this week. When you go back in person next week on Monday, January 11th, you're going to need to make sure that Volume 2 math book is with you as well when you head back to school virtually. You also just keep that in mind. You're going to need that Volume 2 book. So we will use that the rest of the school year. So our learning target specifically today is I can evaluate simple algebraic expressions. And so what is that? What does that mean? There's a short video you'll see on the agenda under the lesson here that says algebraic vocabulary, and highlighted, I put watch this video. So it's a short 4-minute video, just talks about the vocabulary that we're going to see throughout the chapter. And then right underneath that, it says vocabulary definitions. Lined paper is needed to follow along. So I'm going to go through with you the vocabulary, and on your lined paper in your notebook, you're going to take notes. There's about 6 vocab terms that we need to know. And so we're going to write those definitions down. We're going to look at some examples, and then tomorrow talk about them a little bit more in the problems. After that, the last couple things that you're doing to end the day today for math is you're going to review order of operations, and that's in Buzz Math. And why? Well, as we go through algebraic expressions, you'll start to see in some of our examples tomorrow that order of operations is actually going to have to occur as we go through algebraic expressions, meaning as we go through and evaluate the expressions, as we simplify, we have to make sure that we use PEMDAS, the Please Excuse My Dear Aunt Sally. And so I want you to review that. There is going to be 2 lessons in Buzz Math, so you see that on your screen right now. One is called Evaluating the Order of Operations with parentheses. And then the next one is called Evaluating the Order of Operations Numerical Expressions. These 2 right here. So these 2 are going to be part of Chapter 5. I'm not taking a grade, or we're not taking a grade on these today. We're going to take a grade at the end of the chapter on the Buzz Math lessons that you do for Chapter 5. So please make sure you are working on these and getting them done. Eventually, again, at the end of the chapter, you will see these as a part of your grade. So review these, go through these. There's 10 questions each, so 20 questions total, understanding and remembering those order of operations, okay? So then once you do that, it'll also tell you on the agenda, integer practice in that quiz. So the integers that you did with Mr. Terpstra in Chapter 3, you'll need to know those rules and be fairly comfortable with them to go through and evaluate algebraic expressions. And so we had in that chapter, Chapter 3, we had you go into that quiz a few times and practice your integers. So as a reminder, right, here's the website. And under the integers column in arithmetic, so exactly where I'm pointing here, and you have the option to choose. I would honestly do all 4. I would do add, subtract, multiply, divide, but you could, if you wanted to just start with add, subtract, you're more than welcome to, or just multiply, divide. That's whatever. But honestly, I would probably do all 4 together because they're going to be mixed in within your algebraic expressions. And then just make sure you have negatives checked. And then the parentheses, if you want them or not, it's up to you. You can turn that on or off. Here is your choice as well with the length and the level that you want to practice. I would say today to practice your integers, because it's been a few weeks, you take maybe 15 minutes and go through and practice those. Do a length of 10, do 20 at a time. That's fine. And then change your levels up. If you want to start real basic again because you can't remember, then try a level 4. If you feel pretty good about your integer rules, and increase it and go to like a level 10. It is your choice. Just remember that when we did integers in chapter 3, you couldn't use a calculator. If you want to have your integer rules in front of you, you absolutely can. In fact, that's all even on our videos in, November, I believe. You can go back, and December. You can go back to Mr. Terpster's videos and links on the calendar for math, and those integer rules are there for you as well. So coming back here before we start, everything I just talked about is on the agenda here as far as how the day is going to go. Since it's virtual, don't forget that these helpful links down here. So when you can meet with me from 8 to 9, and 1 to 2 if you have any questions in regards to math. If you have Mr. Terpstra, he's 8:30 to 9, and then 1:30 to 2. And then Mr. Whalen, 12 to 12:45, and then 1 to 2. So if you need us, this is the time that you can find us. Coming up this week, just heads up, by Friday, after we do a couple lessons in chapter 5, we're going to have a quick check in Schoology. And then Alex is back up and running again. So this week, it is due Sunday. So let's get going. We're going to go you're going to go next to this vocabulary video. Watch that video for 4 minutes. And then I will meet you back and we will do some vocabulary definitions. Make sure you have lined paper and a pencil. I'll see you in a few. Okay, so we're back. So let's take a few minutes, and on your lined paper, please, let's look at some vocabulary. I do need you to write this down. So what you see in front of you right now says Chapter 5, Algebraic Expressions Vocabulary. Ooh, and I already made a mistake. There should be 2 S's there. There we go. So we're going to start with the first term. And it's just algebraic expression. So on your paper, go ahead and start to write that down. I'm going to read the definition for algebraic expression, and then I'm going to pause so you again have the opportunity, to get that written on your paper, and then we're going to talk about some examples. So an algebraic expression is an expression that contains variables, numbers, and at least one operation. So an expression that contains variables, numbers, and at least one operation, algebraic expression. I'm going to pause, make sure you have that definition written down, and we're going to look at some examples in just a minute. Okay, some examples of an algebraic expression. So if I have something like this, n plus 2. That's considered an algebraic expression. It contains a variable, and we're going to talk about variables in just a minute. Contains a variable. There's the n, the variable. It contains a number, 2, and it has at least one operation. It has an addition sign in between. Variable, addition sign, number, algebraic expression. Here's another possibility. Okay, so if I did c minus 3, my variable is c, my one operation there is a subtraction sign, and my number is a 3, c minus 3, algebraic expression. Let's look at another one. So this time I'm going to make it a little different. Let's go for x plus 8. So I still have my variable. Okay, there's my x. I still have an operation. I have my plus sign. And I still have a number. It's 8. This is an algebraic expression. It just looks a little bit bigger than the previous 2. There's a 4 in front of the variable, and that's okay. Let's do one more. Another example could be 2y minus 1 plus 4. So I have my variable, which is y. I have two operations here because it says I have to have at least one. I have a subtraction sign and I have an adding sign. And then numbers. I have a 1 and I have a 4 here. So 2y minus 1 plus 4. So you would have realized or hopefully seen here with these examples of algebraic expressions, none of these have equal signs. And so in the video that you watched previous to us doing this vocabulary, it did talk about algebraic expressions and it talked about equations and the difference between the two of them. An expression, no equal sign. When we get into equations in chapter 6, absolutely, you're going to see equal signs because you're going to be solving for a variable. Right now, these are just considered expressions. So I'm going to turn the page and go to the next vocab term. At any point in time when we're going through this vocabulary, if you need to pause the video to take notes to catch up, then please do. Make sure you do. And you can always go back if you miss something. So I'm going to go to page 2 here. And the next vocab term that we're going to look at is term. Term, it says when addition or subtraction signs separate an algebraic expression into parts. Each part is called a term. So I'll read it one more time. Term, when addition or subtraction signs separate an algebraic expression into parts, and each part is called a term. So let's do an example. So if I said 6x plus negative 2x plus negative 4, and let's go plus 3. Okay, so let me change the color here. A term, add or subtract signs have to separate each term. This right here, this 6x is a term. There's an addition sign separating. The next term you see here is negative 2x. An addition sign is separating. The next term you see is negative 4. Again, another addition sign is separating. And the last term you see here is a positive 3. 1, 2, 3, 4. There are 4 terms in that expression there. 4 terms. So you're just counting, you're just looking at how many terms you have in the expression. You're just counting to see. It's always going to be separated with an add or subtract sign. We'll do some more examples of this week, but right now, understanding is just each individual term in the expression. When you count, in this example, it's 4 terms, okay? Variable. So, variable is a term I'm sure you've heard, and it should sound familiar. It's a symbol that represents an unknown quantity. And so that could be any letter in the alphabet. So example-wise, I think the most common that you're going to see for variables is X and Y. And this is how I make my Z's. There's a Z. You'll see those the most common. We'll also see, like I used an example on one of the first definitions, I used N. You might see C or A. B is another common one. R, P, I can go on and on and on. You'll see different variables in different situations. And again, these are probably the most common. Sometimes when we start to get into stories with algebra, your variables will represent a certain item in the story. We might need to use a variable to represent something in the story. And so maybe P stands for price, or maybe, usually I didn't put T in here. T usually stands for time. So you'll start to see more of that when you want to pick a variable that associates with something. But again, right now, variable is just really any letter in the alphabet. All right, I'm going to keep going. We have 3 more. And again, don't forget, you can pause as you go to keep up, go back, whatever time you need. So I'm going to go to page 3. And the next one we're going to look at is coefficient. So this is a numerical factor of a multiplication expression that contains a variable. Coefficient, the numerical factor of a multiplication expression that contains a variable. Okay, so if I said 2, I'm going to actually make that a different color. 2p. That 2 that you see right there, this is your coefficient, numerical factor of a multiplication expression. This is multiplication, 2 times p. The number in front of it, 2, is the coefficient. Let me do another one. -6 x. I did it again. I was trying to do color code a little bit for you here. X. And then that -6 in front, right here. This -6 is your coefficient. It's the number in front of the variable, the numerical factor of a multiplication expression. Again, these are multiplication expressions. -6 times x, 2 times p. The numbers in front of those variables are your coefficients. I'll do one more. Let's do just n. Actually made that mistake again, so I can color code a little bit. So if I just said n, what is the number in front of that? Because there really is one in front. There is a coefficient, we just don't see it. And so I'm hoping some of you know that when a variable stands by itself like that, and you don't see a number in front of it, it's always a 1. It's always assumed there's a 1 in front of that variable. The coefficient is 1 in this case, 1n. 1 is the coefficient, the number in front of the variable. Okay. Constant. So a term without a variable, a fixed value. So that's really any number. So it could be 7. It could be -10. It can be 3. It could be -5, -1, 6. So it's just a number. It's a positive or a negative number that doesn't have any variable next to it. It's a constant. Okay, so I have one more vocab term, number 6. And so I'm going to turn to the last one. As always, pause if you need to before you keep going. Last one, number 6. So like terms. These are terms whose variables are the same, terms that are like each other, essentially. Like terms whose variables are the same, terms that are like each other. So I'm definitely going to do some more color coding here. And I'm trying to think of the best way to do this. I think I'm going to do some black ink first. So let's say 3n plus, -5n plus -4 plus n plus let's go 9. Okay. Like terms. Variables are the same. So you'll notice what I did is I put n's in blue. Those 3 terms, 3n, negative 5n, n, 1n, are considered like terms. So like terms, I would group together 3n, negative 5n, and n, 1n. These are like, they're the same, they're like each other, they have the same variable. Each one of these has an n next to it. And if you want to, if it makes you feel better, you can put a 1 in front of that n, okay, like we just talked up above. Those are like terms. Now, you have other like terms in here. We talked about constants. And so we talked about constants are numbers without variables. So the other set of like terms here are negative 4 and 9. So again, these are constants, but yes, they're also considered like. They don't have a variable next to them. They're constants. They are considered like terms. So in this expression right here, we would see only 2 sets of like terms, the n's and then the constants here. We will go through tomorrow. My plan is in the warm-up is to do some examples together to get you used to this vocabulary. And so I'm going to stop with the vocab and the definitions and the examples with you, but know that tomorrow, before we start in the book, we're going to do a couple more of these just so you understand what each vocab means and how you apply it. So as far as vocab goes, you're all set. So you should have watched the video. You should have now seen and done the vocab and have that in your notebook. And the next place that you're going, like I said on the agenda, is you're going to head into BuzzMath, which just logged me out, and you're going to get into those order of operations that I showed you earlier. And then you're going to do, I'd say, like again, about 15 minutes of integer practice, just to go back and review your rules for add, subtract, multiply, divide integers. Okay, so it's good to be back, and I will see you again tomorrow to continue with chapter 5. I hope you have a great first day back to school, and we'll catch you later. See ya.